Okay, so now we're on journal 47 and we're going to start out with our bell work. So if you remember from the last lesson, we learned about how to rewrite exponents to logs and how to write them from logs to exponents, and also how to graph them. So now what we're going to take a look is evaluating. So looking at these two problems here, it's asking you to rewrite the log in an exponential form. So if you remember for last week, we learned that if you have a log, well, logs are written with a subscript that represents the base, this little tiny number that will go here, like the 4 and the 3, is your base. And then after the base is your value, call that A, and then the logs on the other side of the equal sign is your exponent. And so we learned how to translate this into an exponent form. And if you remember, I used that heart trick to do it. So I start with my base, go to my x, and then my value, or my a. So this is b to the x power equals a. That motion from b to x to a helps me write out as an exponential form. So I'm going to do that with here, where I'm going to rewrite it as an exponential form. So I'm going to start with 4, go to x, then 64. So this is 4 to the x power equals 64. So when I write it this way, I'm just trying to figure out what x is. I'm solving for x. So what does the exponent need to be on this 4 to make this a 64? Well, it's 3, right? Because 4 to the third power is going to give me 64, right? Because 4 times 4 gives me 16. 16 times 4 gives me 64. So my answer here needs to be A3. Sorry about that Google timer going off in the background. So where were we? We were talking about rewriting it as an exponent form and then figuring out what x value or what exponent would allow it to get that value. So with this one here, let's do that heart hack again. So from 3, let me do that in pink. So we're going from 3 to x to 3. So this is 3 to the x power equals 3. So what does the exponent need to be here to make this 3 a 3? Well, x to the first power. So when x is equal to 1, right? 3 to the first power is just itself. That's what we've learned last week. So in this case, it looks like x is equal to 1. So it looks like with these, helping us rewrite it as an exponent form allows us to evaluate logs and solve for x. But now, this is kind of a process here. You have to write it as an exponent and then try to figure out the value. Is there a way to just go straight from the log to the value? In other words, like if I can calculate what this value is without writing it as a exponential form? Well, there is. And we use the calculator to help us out. So here in the next slide, I'm going to show you how you can do it on the calculator. Okay, so now what we're going to talk about is something called the common logarithm. So in general, if the log doesn't have a subscript, okay, like the definition says here, then by default the log base is 10. So whenever log is written without a base, by default it's 10. Just like how you think of roots, like when you see a square root, you don't see the 2 being written outside the root, right? But you can assume that it is a square root, that there is a 2 outside. Same thing when you have x to the, like you have an x, it's always to the first power. If there isn't a power written. So by default for logs, if there isn't a base written, it's always 10. And you see this on the calculator a lot. So I'm going to show you here how it looks like on the calculator. Let me turn on the video here. Get the video started, flip my camera. Okay, so you can see here on the calculator, there is a log button right underneath the x square button. So I'm going to clear this out. So if you hit this particular log button, okay, notice that it doesn't have the base written. So this one's a log base of 10. So what I'm going to do here is evaluate. Let me make this smaller. There we go. and figure out the values for like the first one here. So this one here, see, I can grab my pointer. Yeah, there we go. So we're looking for log 15 here. So I'm going to type that in my calculator. So log 15, close parentheses. I'm going to hit enter and get a value. And it looks like my value is about, I'm going to round to 3 decimal places. Grab my pen. So my value looks like it's 1.176. Okay. I'm gonna plug in the other values here. But before I do that, I'm gonna show you another way to get logs in your calculator. So what if you wanted logs and you didn't want a base of 10, right? That becomes a very appropriate question to ask because a lot of logs don't have a base of 10. Well, here's another way to get another type of log where you can change the base. It's in the math button. The math button is the awesomest button because it does a lot of different features. So if you hit math and you use the arrow key, go down to where you see log base. So for me, it's at A is log base. I'm going to hit enter and I get this template. Notice that it makes a space for where I could write my base, right? So I'm gonna, for that one there, I'm gonna do the problem where it's this one here. I'm gonna do a 10 and plug in a 15. Oops, my bad. I'm gonna put in 15 because I wanna see if this really is the same. So remember that this one here is just a log base of 10 with 15 inside. And this one, I forced the base to be 10 and put a 15 inside. So they should give you the same value. And they do. Notice I got the same numbers here. So in this case, definitely works out. But try out the math button if you want to change the base other than having it at 10. So let's figure out the other number. So I'm going to do log 0. Ooh, it throws me an error domain. In other words, it looks like B, if the calculator ever does this, that means that the value is undefined. So in this case, if I go back to here, this one is undefined. All right, and we'll take a look why here in a sec, but let's answer all these questions first. Let's use the calculator to get all of them. So now I'm gonna try to do it with the log, oh wait, I need a different base, so I have to hit math. I'm gonna scroll down to log base. I'm gonna change the base to 1/2, so I can do 1 divided by 2 for 1/2. And then I'm gonna put in 8. Let's see what my value is. It looks like my value is -3. Hey Google, turn off timer. Sorry about that. I'm cooking while I am making this video, so excuse my background. Okay, and then for the last one here, it's a log base of 3 to the -9. So I'm gonna do math again, and I'm gonna go to that, let me see if I can get away from that light there. There we go. So I'm gonna do math, then I'm gonna go down to log base, hit enter, and now I'm gonna press in the 3 and the -9. Let's see, -9, and hit enter. Oh, would you look at that? It says no non-real answers. Okay, so this here looks like it's also undefined. So I have another undefined answer. Okay, so let's understand why this is undefined. So I'm going to close this video now. Pause this. Okay, so let's take a closer look at these two problems, okay? So the first one here, log 0. Why would that be undefined? Well, let's take a closer look. So this one is log 0. Now, the base here, if there isn't a base, is 10, right? And I want to know what the value of this is manually. So what I can do is I can set this equal to x, and then do my heart hack and change it to an exponent form. So let's do that. So this is really 10 to the x equals 0. And as you can see here, this is actually kind of strange, right? So this is saying something 10 to some power gives me 0. Well, what could that power possibly be, right? Well, we can try a few numbers here. 10 to the 0 power is 1, so that 0 can't be it. 10 to the first power is 10, and if I keep raising this power, this number is just going to get bigger and bigger. So it's not a positive number. If I try a negative number like 10 to the negative 1, all I'm going to do is flip the fraction, just get a fraction. I don't get a 0. So you can see here there are no values or exponents that could make 10 be 0. And so in this case, we have an undefined value because there's just not an exponent that makes the base 0. Now let's take a look at this one here. So for the second one, I have log, so I'll do this one to the side here. So I have log 3 negative 9, and I'm going to also set that equal to x because I want to change this to an exponent form. So I start with my 3, go to my x, and then my value. So this is 3 to a power gives me negative 9. Now, I don't know about you, but I don't know how to get a negative 9. Like, think about it. If I were to cover this negative for a sec, 3 to the x equals 9. Well, when 3 is squared, I get positive 9. But how do I get the negative, right? Well, in this case, I don't. It doesn't exist. So it looks like for the negatives, it doesn't work out. In fact, for logs, logs can't be 0 or can't take in 0, and logs can't take in negative numbers. So keep that in mind. We're gonna apply that later on, but just keep in mind that logs can't take in zeros and logs can't take in negative numbers. So let's check out the next slide here. Okay, so now we're going to take a look at the property of equality for exponential functions. So this property is pretty simple. All it's saying is that if you have two equations with the same base, so notice that these two, this equation here, this side is equal to this side, right? The bases are the same. Then they must have this have equivalent exponents. So all that's saying is that if the base is the same, then the exponents here, so the exponents x and y have to be equal to each other. So whenever the base is the same, the exponents are equivalent. So in this case, this little small example here, they're both a base of 4, so that means the x and the 2 are equal to each other. In other words, x is equal to 2. That's it. That's what the property is saying. So you have to check if the equations have the same base first. So we'll take a look at a couple example problems here using this property. Okay, so let's take a look at these two examples here. So the first one here for part A, so we have to check if they're the same base first, and it looks like they are. They're both a base of 2. So in other words, I can set the exponents equal to each other. I can take this guy and set it equal to this side based off my property rule. So I can say x plus 1 is equal to 7. So then, well, I just have to solve for x, right? So to get this x by itself, I need to subtract 1 to both sides. That cancels. So x is equal to 6. And that's my answer. Done. That was easy, right? Let's try it one more time with the other problem here. So this one here, the bases are both the same, 2. So in that case, I can say that the exponents are equal to each other. So that's saying that 2x plus 1 is equal to 3x minus 1. And then I would try to get x by itself. So let's see what we can do here. Maybe I'm going to add this one to this side and that cancels out. So I have 2x plus 2 equals 3x. And then I'm going to, I guess, maybe subtract this 2 off. So that cancels. So I have 2 equals 3x minus 2x is just 1x. And so x is equal to 2. And that's it. So I got x by itself. So kind of like a reiteration here, you have to make sure that the bases are the same. Then if they are, you could set the exponent equal to each other and solve for x. In other words, get x by itself. That's it. Okay, so now we're going to take a look at properties for logs. And you'll notice that this one here is very similar to the property before. All it's saying is if the log base x equals to the log base y, in other words, the base of the logs are the same, then you can say that the inside of the values, so the log's values, x and y, are equivalent to each other. So whenever the base is the same, the stuff like that's usually inside the parentheses for logs, you can set them equal to each other. That's what it's saying here. So like with this problem here, notice that these both logs have a base of 5. So that means that this x is equal to 8. So my answer here is 8. And that's it. So I do want to also mention, because this is a log, that's not the only thing you want to check for. So you don't want to just get your x and be done. There is a part 2. So if you remember in the first few slides, we talked about what logs can't be or can't take in, and that was zeros and negative numbers. So whenever you solve for a log, you have to check the answers for logs. Okay, so any log problem you do, you need to check your answer. And what that means is that when you have a log, you have to make sure that inside the parentheses, you can't have a 0 or a negative number. Okay? Because if you do, if you do, that means your answer is going to be no solutions. So you have to make sure that you don't get 0 and you don't get negative numbers. So let's try some practice problems here. Okay, so with these two practice problems, we're going to be solving for the equation, so getting x by itself, and then checking our answers because logs are finicky. They don't take in zeros and they don't take in negative numbers, so we have to take that in consideration. All right, so with the first problem here, let's work this out. So first thing I notice is that both of these logs have a base of 5. So that's telling me that I can actually set these two equal to each other. In other words, I have 2x plus 15 equals 3x. The values are going to be equivalent because the bases are equivalent. And then I have to just solve for x. So let's see here. Maybe I'll move this 2 over, subtract the 2. This cancels, and I have 15 equals 3x minus 2x gives me just x. Oh, would you look at that? It looks like I have x by itself, so x is equal to 15. But hold up, am I done? Not quite, right? Because I haven't checked my answer. So I have to go back in and plug into the parentheses and see if I have any negatives or 0 values. So you don't need to plug it in and rewrite logs. You just need to plug it into the parentheses. So I'm going to do my checking here to the side. So I'm going to check. Oops. Let's see if I can fix that. So I'm going to check x equals 15. So in this case, I have a 2. So I'm just going to use the stuff in the parentheses. 2 times 15 plus 15. Well, 2 times 15 is 30, plus 15 gives me 45. So it looks like when I plug it into the first one, it checks out, right? So this one here, no issues. I have a positive number. It's not 0, it's not negative, so it's fine. Now I'm going to check it with this one here. If I plug in a 15, 3 times 15, That's going to give me a 45. It's also a positive number, and it's not 0. So in this case, it looks like x definitely can equal 15. So this is definitely the correct answer. Okay, so I've checked my answers, and notice that I was pretty swift with that. As long as it's a positive number and it's not 0 or negative, then the x value that you find is legitimate. And I don't do anything with the logs. All I do is just plug it into the parentheses, okay? So now let's try out this one here. Notice that both of these logs don't have a base here. So by default, what is the base? Well, if there's not a base, if you remember from the first slide, it's going to be 0. So the subscript is 0 if there's not a base written. And so in this case, it looks like both bases are the same, so I can set these equal to each other. So I have 5 minus 3x equals 4x minus 9. And so now I have to get x by itself, so maybe I'll add 9 to both sides. That cancels. 5 plus 9 gives me 14 minus 3x equals 4x. And then I could add 3 to both sides. That cancels, so I have 14 equals 7x. And to get this x by itself, I need to divide by 7. Let me do that better. So I'm going to divide this side by 7. So 7's cancel. So x is equal to 2. It looks like 2 is equal to x. And so in this case, it looks like I have my value, but I haven't checked if this is correct or not. So now I'm going to do my checking here. Let me zoom that out just a little bit. So to check, I'm going to plug in that 2 for x into the equation and see if I get a positive number. Because if I do, and I don't run into zeros and negatives, then I'm good. I'm golden. X is the answer. So in this case, I have, if I plug in the 2, that's 5 minus 3 times 2. Well, 3 times 2 gives me 6, and 5 minus 6 gives me negative 1. Oops, it doesn't look like this works out, right? Because I get a negative number. So anytime one of, you don't have to plug it into both. If you plug it into one and you notice you get a negative number, then that there is already saying that this is a red flag. Hey, this is this is going to cause problems when you plug it into log. It's going to be undefined. So I have a negative number. So this is going to be no solution. Okay, and that's it. So I'm going to do one homework problem with you guys. It's number 12 because it's the hardest one on there. So let's do it together, and so that way we can answer some questions. So for 12, we're going to do the same basics. We got to make sure that the bases are the same, and they are. They're both 9s. So in this case, I can say this guy is equivalent. Oops, my bad. This guy is equivalent to this guy. So 3. Oops. Grab a regular pen. 3x squared equals 2x plus 1. And so when I look at this problem here, I notice that it's a quadratic, meaning my highest power here is squared, okay? So in that case, when we're solving for quadratics, it's been a while since we talked about this. So for quadratics, you typically have ax squared plus bx plus c equals 0. And so if you have a quadratic function, the first method you can use is factoring. So if you remember how to factor, or if you want to use slide and divide, you can, but factoring can be very limited. So another great method is called the quadratic formula. All right, so I'm actually going to choose to use a quadratic formula here, but I'll talk about it here in a sec. Let's first solve this problem. So with this problem here, you want to first get 0 on one side. So what I'm going to do, and traditionally what most people do, is they take their right-hand side and move everything over so that the x squared is a positive number. So in this case, if I move over the 2x and the 1 on both sides, I get 3x squared minus 2x minus 1 equals 0. Okay? So in this case, now I can use a quadratic formula. So if you remember the quadratic formula, it's x equals negative b plus or minus the square root b squared, b squared minus 4ac all over 2a. So here's my a, here's my b, here's my c. If I were to use this formula, let's see how far I go. So x is equal to negative 2, so negative 2 in here, plus or minus the square root of b squared, so that's negative 2 squared, minus 4 times a, which is 3, times negative 1. 2 times 3 gives me 6. So if I work this out, negative times negative makes a positive 4. Negative 2 squared is going to give me a positive 4. And negative 4 times 3 gives you a negative 12. Times another 1 gives you a positive 12 over 6. So if I'm working this out, okay, I think I got cut off a little bit, but basically all I did was I added the 4 with the 12 to get 16, square root of 16. And so if I were to simplify this, I would have 4 plus or minus 4 over 6. Oh wait, where did I get this 4? Oops, my bad. Let's see if I can erase that. So that shouldn't be a 4, should be a 2. My bad. So I have 2 plus or minus 4. And when I get to this part here, what do? Well, I have to split it up into two equations, one with a plus 4 and one with a minus 4. So I have x equals 2 plus 4 over 6. And then I have x equals 2 minus 4 over 6. So looking at this here, 2 plus 4 gives me 6. 6 over 6 is 1. So x is equal to 1. 2 minus negative 4 gives me negative 2 over 6, which is negative 1 over 6. I'm sorry, negative 1 over 3. So now what we have to do is check our answer. And I know some of you are groaning in the background, but we do need to do this part to see if they are true. So to check our answer, I'm going to do x equals 1 first. If I plug it into 3x squared, so that's going to be 1 squared. It's going to be 1 squared is just 1. 1 times 3 gives me 3. Okay, so that seems like it worked out, right? So we got a positive number, so no zeros or negative numbers, looking good. Now I'm going to try to plug this into the other half, the 2x plus 1. So I'm going to plug the 1 into there. So here I go. So I have 2 times 1 plus 1. Well, 2 times 1 gives me 1, plus 1 gives me 3. And so it looks like 1 checks out. Nicely done. Okay, and then we have x equals negative 1 over 3, and we're going to check that. Okay, so this one's a little tough because it's a fraction, but it's not too bad. So I have 3x squared, so if I plug that in, 3 1/3, negative 1/3 squared. Okay, so if you take this power here, negative 1 over 3 squared is 1 over positive 1 over 9. If you don't know why, well, that's when you do negative 3 times negative 1/3. 2 negatives make a positive. 1 times 1 gives you 1. 3 times 3 gives you 9. And so that's where it comes from. Okay. And then 3 times 1 over 9 is just going to be 3 over 9, or 1/3. But either way, you get a positive number. You don't have any zeros or a negative. So it looks like plugging in -3 doesn't cause any bad things to happen. So we're going to do this again and plug in for the other one. So this is going to be 2 times 1/3, -1/3, plus 1. And if you work this out, 2 times -1 over 3 is just -2 over 3 plus 1. And so if you combine these two, well, you're combining fractions. So in this case, you can put this in your calculator, honestly. But if you combine them, you'll get 1 over 3, okay? Which is a positive number, and you're fine. So if you don't get a 0 or you don't get a negative number, that means that the answer, or the x value, is correct, or doesn't have any issues. Okay, so it looks like our answer is x equals 1 and x equals -1 over 3. So both of these answers are valid. I hope that helps you out with some of the homework problems. And if this stuff is not making any sense, let me know in class if you have any questions about solving logs or exponents.